quick bite on transportation. It is having very good weightage in GATE exam, 8 to 10 marks, minimum is 8. Last year in one set it has reached to 11 marks also. So, it fluctuates anything above or equal to 8 marks. For GATE is concerned, this is our syllabus. You have transportation infrastructure, nothing but highways. This is highway and mainly highway geometric design. So, in this highway geometric design, you have railway geometric design also along with airport. The geometric design of highway, geometric design of railway, geometric design of airport. After that, pavement design along with the properties of highway material. Next is traffic engineering. So, totally you can say 3 parts. There may be a chance of 4 to 5 marks from highway geometric design, including railway plus airport here. Generally, if a question comes from railway, then there is no chance of a question from airport. If question comes from airport, there is no chance of question from railway till now. In future, there may be a chance of a question from both railway and highway airport also, but in railway and airport you have only geometric design part, very simple and very sweet and short part. So, no need to worry much about it. Next, highway pavements will have a chance of 2 to 4 marks here. Traffic engineering is having again 4 to 6 marks. Sometimes it may go up to 6 also. Minimum is 4, you can go up to 6 marks also. So, compared to the geometric design, there is a slight higher weightage of traffic engineering. Be careful about traffic engineering because it is having lot of miscellaneous theory things and then empirical parameters also. You have to be very careful and cautious on the traffic engineering. So, spend more time on traffic engineering. Highway geometric design is straightforward, formula oriented. If you know the formula and little specifications, that is more than enough. So, spend more time on traffic engineering first and then come back to the highway geometric design of railway, including railway and airport, then come to the pavement design and highway material. In pavement design and highway material, less weightage, it is from 2 to 4 marks. Especially in highway material, you need to just go through the material testing, especially aggregate testing and bitumen testing. So, in this aim, apparatus and specifications, if you remember, it is more than enough. No need to go through the procedure of the experiments and all. Now, if you come to the type of questions, you all well know there are multiple choice questions, we call it as MCQ. For MCQ, if there is a wrong answer, 1/3 negative. If you keep wrong answer, 1/3 is negative. For 1 mark question, 1/3 is a negative mark. For 2 marks question, 2 into 1/3, 2/3 is negative. So, multiple select questions will be there, very similar to that of multiple choice questions. You have, but here more than one option may be correct here. You can select more than one options among A, B, C, D. So, no negative here, and the numerical answer type questions, you need to fill the answer in the form of a numerical only. That means no choice at all. You need to fill the answer whatever you got as per their requirement. Sometimes they will ask you to round it to the nearest integer, sometimes they will ask you to round it to 1 decimal place, 2 decimal place, like that. But if answer variation is there, they will accept the correctness within some range. But here there is no negative marking, that is the advantage. So, you must answer all the questions of multiple select and numerical answer type questions. Nowadays, multiple select questions importance is increasing. 3 years back, there were no multiple select questions, but recently they have added multiple select questions in the GATE also. Usually, how these are the type of questions we expect in the GATE exam. Memory recall, that means it is based on the formula and specifications. This is given by the GATE officials. In the official website, this is given. That means there will be some memory oriented questions based upon the formula and specifications. So, you must by heart, you must write the formulae along with the specifications. Some specifications like what is the reaction time, what is the height of the driver above the road surface, like that. Comprehensive ability to understand. If you understand the concept, based upon the concept, they may give you some theoretical questions or some numerical aptitude type of question, because GATE is graduate aptitude test. So, few questions are based upon the aptitude also. A person with good aptitude can answer the question without much of difficulty. So, that type of questions are comprehensive questions. Application type, whatever theory you have come across, whatever formula you have come across, you can apply that formula and get the answers. Application, that may be again a formula substitution type, and there may be analysis type of questions also. You need to analyze the question, you need to think and then answer the questions. There is combination of different topics, synthesis. They may combine stopping side distance and summit or valley curves. They may combine 2-3 chapters together, and sometimes they are combining different subjects also. Like subject of engineering mechanics can be linked to the transportation, and mathematics can be linked to the transportation. Especially the negative Poisson's distribution of mathematics is linked to the transportation. With the transportation terminology, they'll give you a new question based upon the mathematics applications. Like that, synthesis questions will also be there, but a very less number of questions will be there. So, these are the 5 type of skills you need to improve while preparing for the GATE exam. So, memory is important. For that, regular recollection of the formulae and the specifications are required. So, what you need to do is you need to maintain a short notes with all formulae. Don't say that RSR, please give a formula sheet for us. You need to prepare on yourself, so that you will get more clarity on what you are writing, and you will get more understanding, more ability, and more comprehensive abilities you can develop by writing on your own. So, don't ask, please send one formula sheet, I will write. So, you prepare on its own. Even if your friend is preparing, don't take it. You prepare on your own. No need to spend separate time on it. As you go through, whatever you read from that, if any formula or important things are there, just jot down on a separate notebook, and that will be your formula book. That's it. Now, come to the geometric design. The geometric design includes geometric design of highways, includes historical development, road plans and surveys. I don't think so questions will come from this area. You can directly ignore these areas, because history never repeats, and road plans, the type of plans and all, is old version. Nobody will ask you, because GATE is a aptitude, graduate aptitude test. Nobody will ask you all these things. But surveys you might have come across in the survey subject. So, that is more than enough. In survey, you might have come across the surveys related to highways, surveys related to buildings, surveys related to canals. So, there if you have little idea, that is more than enough. Now, coming to the main things of geometric design, you have stopping side distance, overtaking side distance, horizontal curves, setback, transition curves, vertical curves. In vertical curves, there are 2 types, summit and valley. So, from this there is a scope of 4 to 5 marks question, and stopping side distance is important. Overtaking is okay. Horizontal curves is important. So, the other areas questions may come, but each and every chapter will be having 3-4 formulae, sometimes 1 or 2 formulae. So, do not neglect any of the part in this topic in the geometric design of highways. So, SSD, OSD, horizontal curve, setback distance, transition, vertical curves you have summit and valley, that is enough. Next is traffic engineering. We have macroscopic parameters like flow, nothing but traffic volume, speed and density, and relation between these values are important for us, especially the capacity calculation based on these values are important. Next is macroscopic parameters like time headway, space headway. Micro means small, macro means big parameters, large parameters. Capacity under prevailing conditions are important. Then the green shield method is very important. Green shield linear speed density model is important. Questions are repeatedly coming from the green shield. Next is speed and delay studies. I do not think so question will come from speed and delay studies. You can ignore if you want speed and delay studies. Point of conflicts is a theory memory oriented area. Then design of rotary intersection, rarely questions will come. Highway lighting also very rare, parking also very rare, accident also rare areas. So, important areas are, this is important, other things are not that much important. So, these are all important, and in this area design of rotary may be coming into the picture. Point of conflicts theory, try to remember. Other things are rare to get it in exam. Now, next signal design, Webster's method is very important, especially the cycle time calculation and Webster's delay calculations. We will just talk about these things. As per our, we have very limited time, so we will just overview on all the things. Next, coming to the pavement design, we have flexible pavement design. In the flexible pavement design, we have calculation of equivalent single wheel loads, rigidity factor calculation, equivalent single axle load, vehicle damage factor, cumulative standard axle calculation is very important for us. Next is rutting and fatigue criteria is a rare issue. Next, rigid pavement design, we have wheel load stresses, warping stresses, frictional stresses. Frictional stress calculation is important, and a critical combination of stress is important, especially in joints. We have longitudinal joint, expansion joints and contraction joints. Among these, dowel bar design and the tie bar designs are important. Go through these areas. Okay. Critical combination of stresses go through. Summer midday, winter midday, like that we have different combinations as per IRC. Try to remember as per IRC. Next is material testing. We have properties of subgrade, properties of aggregate, properties of bitumen, and Marshall mixed design method is important for us. There is a chance of 2 marks question, numerical question from Marshall bituminous concrete mixed design. So, properties of subgrade includes CBR test and plate load test. CBR test and plate load test, go through this. Plate load test and properties of aggregate and properties of bitumen. The properties of aggregate will be helpful in the construction aggregate also. Especially you might have come across in RCC where you have come across cement aggregate and water. That aggregate and this aggregate, road aggregate and building aggregate, construction aggregate are the same. Next is in geometric design of railway, we have super elevation, cant and cant deficiency, more than enough. These two areas, if you remember, it is more than enough, and some parts of geometric design. Transition curve, rarely they may ask you in railway. Length of runway, in airport, length of runway, length corrections, and the taxiway, especially the exit radius of taxiway is important for us. Exit radius calculations are important for exam point of view. Now we will just touch the geometric design part. Gradient is slope along the length of the road, camber is slope across the length of the road. So there may be chance of question on grade compensation. Grade compensation is the reduction given to the gradient when a gradient comes along with a horizontal curve. If there is a gradient coming along with horizontal curve, say suppose you are going on a hilly area, this is a straight road, but at some locations what's happening is there will be gradient coming along with horizontal curve. So if you look at this portion, the road is going up and up plus it is taking a turn. Road is going up and up and it is taking a turn. Here you have gradient plus horizontal curve. If gradient is there plus curve is there, then heavy vehicles may not go up. To facilitate these heavy vehicles to go easily up, we reduce the gradient. That reduction given to the gradient is called grade compensation. So grade compensation in percentage is given by 30 plus R by R or 75 by R. Empirical formula 75 by R, whichever is least. R is equal to radius, you need to substitute in meter only. Don't substitute in any other units. It's empirical formula, the units are fixed. You need to substitute R in meter only. And the compensated gradient is the gradient whatever you are providing on the road after grade compensation. This is nothing but original gradient minus grade compensation. Compensated gradient is equal to the actual gradient on the road minus grade compensation. And what IRC says is, if the gradient is less than or equal to 4%, no need of grade compensation. If the gradient less than or equal to 4%, no need of grade compensation. No need to give discount to the gradient if the gradient is flatter than 4%. So you need to remember this formula and remember this point also. We'll take a small numerical on this concept. Try this question. The gradient on a highway is 5%. The highway is encountered a horizontal curve of radius 500 meter. Which of the following statements are correct? Grade compensation is 0.15%. Compensated gradient is 4%. Grade compensation 1%. Which of the following statements are correct? It is a multiple select question. Which of the following statements are correct means it is a multiple select question. Try this question please. The gradient given is 5%. It is more than 4. So grade compensation is allowed. You can allow the grade compensation. What is the allowable grade compensation you can have here? Allowable grade compensation means 5, you can give discount till it becomes 4. 5 is the actual gradient, you can give discount till it becomes 4. So maximum grade compensation is 1%. Allowable grade compensation or maximum grade compensation is 1%. You calculate grade compensation as per our formula 30 plus R by R and 75 by R, whichever is less. As the radius is 500 meter, 30 plus 500, 530 by 500. So here it is 75 by 500. This will be the least. Among the two, we need to pick up the least. Now, this will be the least. 75 by 500 is least. Because here 530 by 500. This is 75 by 500. This is least. No need to calculate both. This is maximum grade compensation. Don't go more than this 1%. 75 by 500 is 0.15%. This is less than maximum allowable gradient, less than maximum grade compensation. So, use grade compensation as 0.15%. If you give discount of 0.15%, the compensated gradient will be actual gradient minus grade compensation. Actual gradient is 5 minus 0.15, nothing but 4.85. Nowadays, multiple select questions are slowly increasing in the GATE paper. Be careful about these multiple select questions, but in multiple select questions, negative marking is not there if you make it wrong. Why to make it wrong? Make it correct. That is our motto. Next, we will go to stopping sight distance. We call it as SSD. The visible distance ahead of driver to stop the vehicle on emergency. The visible distance ahead of driver to stop the vehicle on emergency is stopping sight distance. The height of the driver from the road surface, we call it as capital H. As per IRC, it is 1.2 meter. Minimum height of the obstruction above the road surface is equal to 0.15 meter as per IRC. So, capital H, height of the driver above the road surface is 1.2 meter, 4 feet. Height of the obstruction over the road surface is 0.15 meter, it is adha feet. So, with this condition, the minimum distance required to stop the vehicle is comprising of lag distance plus braking distance. First, driver has to react that I should apply brake. The distance travelled by the vehicle during reaction time of driver is lag distance, and after the application of brake, vehicle moves for some distance and stops. That distance is called brake distance. Lag distance is V into T, brake distance is V square by 2GF. By heart this. V is design speed here in meter per second. Design speed in meter per second. And F is equal to quotient of longitudinal friction ranging from 0.35 to 0.4 as per IRC. As the speed increases, friction reduces. Quotient of longitudinal friction. This is longitudinal friction. More the speed, friction reduces. Till the speed is 80 kmph. After 80 kmph, that means further increase the speed beyond 80 kmph, the friction remains constant. Speed increases, friction reduces up to 80 kmph. Beyond that, F remains constant. .35. Beyond speeds of 80, say for example 81, 83, 90, 100, 120, the friction remains 0.35. At slow speeds, the friction is 0.4. As speed increases, it reduces to 0.35. By the time speed is 80, it is 0.35. Beyond 80 kmph, 80, 90, 100, 120, the friction remains 0.35 only. So, I am giving you this equation for a flat road. This is for flat road. If the road is having gradient plus brakes are not proper, the roads are not flat roads and brakes are not good. In that case, stopping side distance can be no change in lag distance, but brake distance changes, V square by 2G eta f plus or minus gradient as a ratio. Try to remember this. Eta is called brake efficiency, and G is called gradient. Both you need to substitute it as a ratio. Brake efficiency you put it as a ratio, gradient also you put it as a ratio. Plus indicates upward gradient, negative indicates downward gradient. Upward gradient is taken as plus, downward gradient is taken as minus. If brakes are 100% perfect, no loss at the brake, eta is 1. Perfect brakes eta is 1. Flat road gradient is 0. If the road is very flat, gradient is 0. Perfect braking system, new vehicle, brand new vehicle brought from the showroom, eta is 1. If nothing is mentioned, take eta as 1. If nothing is mentioned, take gradient as also 0. Okay. Now, people may ask you safe SSD sometimes. Safe SSD depends upon the number of lanes on the road and direction of traffic, especially in single lane two-way road. This is very important for us. Single lane two-way traffic road, single lane road will have 3.75 meter wide, opposite vehicle also coming. In that case, you should stop and opposite vehicle also should stop to avoid accident. So, safe SSD will be 2 into SSD, because there is no chance to go on to the shoulder also sometimes. Shoulder might have damaged. So, you can't use shoulder for moving the vehicles. Shoulder is used to emergency park. So, in that case, safe SSD is 2 into SSD, that we call it as intermediate side distance. All other roads, any other road, all other cases, safe SSD will be directly SSD calculated by the formula only. Try to remember this first point. Single lane two-way road, safe SSD is 2 into SSD, that is nothing but ISD. In any other case, nothing but single lane one-way road, two lane two-way road or any other road, it is safe SSD is SSD calculated from the formula directly. So, intermediate carriageway, intermediate side distance is equal to twice of the stopping side distance. You need to remember relation between F and G, quotient of longitudinal friction and retardation. A is retardation. So, A is equal to F into G. A is retardation, F is quotient of longitudinal friction. You need to use linear motion equations when time of travel is given in a question. Linear motion equations are to be used when time of travel is given in a question. Linear motion equations, you might be knowing it. S is equal to ut plus half at square, v square minus u square is equal to 2as, v is equal to u plus at. You might have come across these things in your first year of intermediate or 11th class. Okay. Try to solve this question. If the speed is given in meter per second, directly you can use it. Otherwise, if speed is given in kmph, convert into meter per second by multiplying with 5 by 18. The safe stopping side distance, safe SSD they are asking you on a single lane two-way road. This is most crucial. With design speed of 20 meter per second, V is given as 20 meter per second. Reaction time of driver is 2.5 seconds. Quotient of friction is given as 0.35. Whatever is given, you take it. G is 9.81 meter per second square is given. Try to use the given values. So, it is a single lane two-way road. Safe SSD will be, here it is ISD, nothing but 2 into SSD. And SSD can be taken as lag distance plus braking distance. In braking distance, brakes are perfect because brake efficiency is not given, gradient also not given. So, it is V square by 2G into F. Directly substitute, as the V is given in meter per second, directly substitute meter per second. T is reaction time of driver in SSD, reaction time of driver in SSD is 2.5, that is given to you. Use given value, V square 2 into G is 9.81 given, F is 0.35 given. So, 216.5 is option C. Try this question. Two-lane two-way road, safe SSD is 250 meter with all other parameters remaining the same. Safe SSD in single lane two-way road is two-lane two-way road, safe SSD is two-lane two-way, safe SSD is 250. Two-lane two-way, safe SSD nothing but SSD only. SSD directly is 250 meter. Then safe SSD on single lane two-way they are asking. For single lane two-way, this is the most crucial, single lane two-way. Safe SSD is ISD actually, nothing but 2 into SSD. Already SSD known to us, 250 into 2 is 500 meter. So, answer is option B. Okay, like that questions may come for 1 mark. The most critical area is single lane two-way, where safe SSD is 2 into SSD calculated by the formula. Try this question. A vehicle stopped with a retardation of 2 meter per second square. Retardation is negative acceleration. And the quotient of longitudinal friction developed between road and tire. What may be the friction? So, take the modulus of A is equal to F into G, that is what I told you. F is A by G, 2 by 9.81. Nearest answer. 2/10 you take it. Point 2, nearest answer is 0.2. One mark question generally comes like this. We will talk about overtaking side distance. The visible distance ahead of the driver to safely overtake a slow vehicle. The visible distance ahead of driver required to safely overtake a slow vehicle. Overtaking is not allowed on the single lane roads, because on single lane road you can manage only with one vehicle. So, this is a 2-lane road, minimum 2 lanes are required. Say suppose you are going by Audi car and you are following a slow vehicle bench lorry. Initially Audi car driver has to follow the bench lorry with a slow speed, and he has to wait for an opportunity to overtake this bench lorry. So, initially the Audi car driver is following the bench. I am taking all center to center distances. So, this is distance travelled by Audi car during the reaction time of driver. So, in this distance, the driver of Audi car is moving with slow vehicle speed Vb. Bench continuously moves with slow speed only Vb. So, at this particular point, Audi car driver moves on to the next lane, goes on to the next lane. At this particular point, he observes some other vehicle coming from the opposite direction. Creta car is coming from opposite direction. The Creta car comes with a design speed. The Creta car is coming with a design speed from the opposite direction. So, the driver of Audi car identified that the Creta car is very far away. He has moved back to the original position, original lane with increasing speed. So, during this path, blue path, the driver of Audi car is increasing the speed. So, Creta car meanwhile has come up to here, going beyond that is dangerous. So, it has come up to here, say it has come from C to C1, and Audi car initially during the reaction time of driver has moved from A to A1, and then finally it has reached to A2. The bench lorry during the overtaking time of Audi car has moved from B to B1. It is moving like this. Creta is coming from the opposite direction. Audi car is moving forward like this. So, this is the distance travelled by the bench lorry during overtaking time of capital T with a slow speed Vb. Overtaking time is capital T, reaction time is small t. Distance between Audi car and bench lorry before overtaking is say S1. Distance between Audi car and bench lorry after overtaking is S2. I am taking all center to center distances. So, the distance moved by Creta coming from the opposite direction during the overtaking time, I call it as D3, and this distance moved by the Audi car with acceleration is D2. So, overall overtaking side distance is D1 plus D2 plus D3. For safe overtaking, in front of the driver OSD is required, which is the sum of D1 plus D2 plus D3. Actually, the overtaking time capital T, I am not giving you the derivation, it is the 2 into S1 plus S2 by A under root. For derivation, you just go through the class notes. S1 is distance between RD car and bench lorry before overtaking. S2 is distance between RD car and bench lorry after overtaking. If S1 and S2 are not given, use S1 is equal to S2 is equal to 0.7 into speed of the bench plus length of the vehicle. Average length of rigid wheelbase or average length of vehicle is taken as 6.1 meter. L is average length of vehicle or average length of rigid wheelbase. As per IRC, we take it as 6.1 meter. So, if not given, use this formula for calculation of S1 and S2. If not given, only use this. If given, take the given values. Next, if you observe this data, D1 is equal to VB into reaction time of driver in OSD. Initially, RD car is following the bench lorry with slow speed VB. That is why VB into T is D1. That is the distance travelled by RD car during reaction time of driver. T is reaction time of driver in OSD. It is not 2.5 seconds. 2.5 seconds is in SSD. 2 is in OSD. 2 seconds in OSD. Now, D2 from the figure is S1 plus S2 plus VB into capital T. S1 plus small VB into capital T plus S2. D3 is the distance moved by Creta, which is moving with the design speed V. The Creta speed is V. It has moved for a distance of D3 during overtaking time of capital T. So, it is V into capital T. So, if you remember this formulae, you can easily calculate the OSD. For the derivation and all, you need to go through the regular class notes, or otherwise in any of the standard books it is there. The derivation and all you can just go through after the exam, or if you want some clarity you can go through that if you find time. Otherwise, directly by heart the formula and try to use the formula. If not given, velocity of slow vehicle will be design speed minus speed 16. Try to remember it. These are all given in kmph. Capital V generally given in kmph. Small v will be in meter per second. So, velocity of slow vehicle is design speed minus speed 16. If VB is not given, we use it. Okay. This is overtaking side distance in brief. Sometimes they will ask you safe overtaking side distance, like a safe SSD we have taken as previously. Safe OSD. It depends upon number of lanes and direction of traffic. Very critical is 2-lane, 2-way road. 2-lane road with a 2-way traffic. Because in 2-lane, 2-way traffic, opposite vehicle Creta will also be coming, that also to be considered. So, in this case, safe OSD will be, you need to consider D1 plus D2, opposite vehicle D3 also you need to consider. In any other case, safe OSD is given by, opposite vehicle is not a problem at all in other cases. So, the D1 plus D2 only we use. Single lane roads overtaking is not allowed, that is why we use overtaking zone on single lane roads. overtaking zones used on single lane roads for overtaking purpose. That overtaking zone is nothing but widened portion of the road for some length, only to facilitate the overtaking process. Single lane road width is 3.75 meter. In that 3.75 meter of width, overtaking is not allowed. So, in the overtaking zone, they will make the road into double lane road. So, this is length of overtaking zone. Minimum length of overtaking zone will be length of OT zone I am writing, overtaking zone. Minimum length required is 3 times of safe OSD, minimum. Desirable length is 5 times. Five times of safe OSD. So, minimum length of overtaking zone length is 3 times of safe OSD, desirable is 5 times of safe OSD. And here the safe OSD is based upon the width available at the overtaking zone. Actually, width available at this overtaking zone is a 2-lane road width, 7 meter will be available. So, if you apply two-way traffic here, safe OSD is D1 plus D2 plus D3. If you consider only one-way traffic here, the safe OSD is D1 plus D2 only. D3 will not come in case of one-way road. So, safe OSD based upon OT zone is 2 lanes. Generally, OT zone has 2 lanes. If it is one way, 2 lane one way, safe OSD is D1 plus D2 only. If it is 2 lane 2 way, if you allow 2 way here, safe OSD is D1 plus D2 plus D3. If opposite vehicle is allowed, D1 plus D2 plus D3 is required. If only one way traffic is allowed at the overtaking zone, D1 plus D2 is enough. Okay. Try this question. A 1 mark question, give me answer, multiple choice question. Any doubts please? In which of the following roads maximum overtaking side distance is required? Maximum means in which case opposite vehicle is also to be considered, D3 is also to be considered. Two lane two way, you require safe OSD as D1 plus D2 plus D3 also required. 2 lane one way, 4 lane divided highway. So, here safe OSD is D1 plus D2 only. Single lane one way road, overtaking is not allowed. Unless otherwise you have overtaking zone. The overtaking zone is not a single lane road, it is a widened 2 lane road. So, answer is option A. Try this question. It is a numerical answer type of question, needs time to solve. On a 2 lane two-way highway, two-lane two-way means opposite vehicle is also coming into the picture. D1 plus D2 plus D3 also to be considered. Acceleration of overtaking vehicle is 1 meter per second. Distance between overtaking and overtaken vehicles before and after overtaking is 20 meter. Speed of slow vehicle is 20 meter per second. Design speed of highway, that is speed of the opposite vehicle, is 25 meter per second. Reaction time of driver is 2 seconds for OSD. The safe overtaking side distance they are asking. Acceleration is given to us. This is acceleration. S1 plus S2 is equal, S1 and S2 will be equal to 20 meter. The speed of the slow vehicle is VB, and design speed of opposite vehicle is V. Driver reaction time for OSD is 2 seconds. First you calculate overtaking time, under root 2 into S1 plus S2 by A. A is 1. So 2 into 20 plus 20, 40 into 2. D1 can be VB into small t, D2 is S1 plus VB into capital T. This is the distance travelled by bench lorry during the overtaking time of capital T. D3 is V into capital T, design speed into capital T. .94. So VB is 20 into 2. This is small v, 25 into capital T you need to take. So safe OSD on two-lane two-way traffic will be two-lane two-way, D1 plus D2 plus D3. Okay.